Hi guys, so today we're going to talk about solving inequalities. Before we talk about how to solve them, I want to review with you the properties of inequalities. Okay, so in a previous chapter we talked about simple one-step inequalities. Okay, one step. So we're going to review the properties so that way we can remember how we did that. Okay, so first, we're going to look at the properties of inequalities. Okay, so the first property we're going to look at is the addition property. And the addition property says if A is less than B, then A plus C is less than B plus C. Okay? And if A is less than B, then A minus C is less than B minus C. All right, so that's the addition property. So now let's take a look at the multiplication properties. Okay, so the multiplication properties say this. If A is less than B and C is a positive number, so C is bigger than 0, then A times C is less than B times C. Our sign didn't change, okay? However, if A is less than B and C is less than 0, so C is a negative number, then A times C becomes greater than B times C. Okay, so also under multiplication is division. So if A is less than B and C is a positive number, then A divided by C is less than B divided by C. If A is less than B and C is a negative number, then A over C becomes greater than B over C. So again, the sign changes when you have a negative number that you're dividing by. All right, so now that we've reviewed our properties, and we use these properties for one-step equations or one-step inequalities. So now we're going to apply these properties for two-step inequalities. All right, so our first example says negative 4x plus 3 is greater than 23. So just like any other two-step equation, the first thing you want to do is take care of the addition subtraction. So I'm going to take care of this plus 3 by subtracting 3. And that leaves me negative 4x is greater than 20. All right. Now to get rid of that times negative 4, I'm going to divide by negative 4, which leaves me x. However, I divided by a negative, which means my sign is going to flip, and 20 divided by negative 4 becomes negative 5. So my answer is x is less than negative 5. Let's say we wanted to graph this. Well, we get our number line, and the first thing we do is we're going to put a dot at negative 5. 1, 2, 3, 4, 5. Here's negative 5. Now notice that x is less than negative 5, but x is not equal to negative 5, which means that the dot on negative 5 is going to be an open dot to show that it's not actually equal to negative 5. It's just at negative 5. Now since x has to be less than, it's less than it's all the numbers less than negative 5. So it's all these numbers over here. Right? It's all these numbers over here continuing that direction. And I remember giving y'all this hint, the arrow that your numbers are going towards should match the direction of your inequality symbol as well. All right, let's look at our next example. We are going to do negative 3/4 x plus 8 is less than or equal to 23. All right, so to solve this two-step, I'm going to take care of my addition first by subtracting 8 from both sides. Now I have negative 3/4 x is less than or equal to 23 minus 8 is 15. All right, now I have negative 3/4 x is less than or equal to 15. So to get rid of this times negative 3/4, I'm going to divide by negative 3/4. But remember, dividing is the same as multiplying by the reciprocal. So I'm going to multiply by the reciprocal, negative 4/3, right? The reciprocal of 3 over 4 is 4 over 3. So I'm going to multiply by negative 4/3. All right, so everything should cancel, including the negatives, leaving me just x. But since I multiplied by a negative, my sign is going to flip. Now 15 over 1 times 4 over 3, I'm going to reduce a little bit. 3 goes into 3 once, 3 goes into 15 5 times. 5 times 4 is 20. It is negative, so I get negative 20 over 1, right? Which is just negative 20. All right, so let's say I want to graph that, right? I draw my number line. I'm going to make my number line by tens, right? So this is negative 10, negative 20. So my first step is to put my dot at negative 20. Since this can be equal to negative 20, that means it is a filled in dot to show it could be equal to 20. And then since x has to be greater or equal to negative 20, greater means all the numbers bigger. So all of these numbers with my arrow going that way. And I can check. My arrow should be the same direction as my inequality, and it is. All right. Okay, so another example, and this one is using the distributive property. We have negative 2 times r plus 4 is greater than 19. So step 1, distribute that negative 2 to get rid of the parentheses. So negative 2 times r is negative 2r. Negative 2 times 4 is minus 8. Then bring everything else down, greater than 19. Now I have a two-step equation. So the first thing I'm going to take care of is my addition and subtraction. So I'm going to plus 8 on both sides, so that way this cancels. Leaving me negative 2r is greater than 19 plus 8 becomes 27. There we go, 27. And now we have to solve for r, so we have to divide both sides by negative 2. Leaving me r. I divided by a negative, which means my sign flips. And 27 divided by negative 2, let's see, that becomes, we have to, negative 13.5. All right. If I was just wanting to know what r was less than, I could have left it as negative 27 over 2. However, I also want to graph my answer, so I went ahead and found what the decimal was. So now I can graph it, right? So I'm going to count by 5s, right? So 0, negative 5, negative 10, negative 15, which means negative 13.5 is somewhere around here. And it's going to be an open dot because it's not equal to negative 13.5. So here's my open dot. And it's going to be less than, so it's going to be all these numbers. And my arrow should be pointing the same way as the inequality, and it is. All right, so now let's talk about variables on both sides of the inequality. So we talked about variables on both sides of solving for variables on both sides. So now we're going to do the same thing, but instead of an equal sign, we have an inequality sign. But the rules stay the same. It's still the same steps, it's just that we have an inequality instead of an equal sign. So let's do an example. We're going to do 2x is greater than or equal to negative 2x plus 8. Okay? My advice to you is always put your variables on the left-hand side when you are dealing with inequalities. So I want all my variables on the left, and I have a variable on the right. So I need to no longer see that minus 2x. So I'm going to do the inverse of minus 2x, or negative 2x. I'm going to add 2x to both sides. So when I do that, 2x plus 2x on the left-hand side leaves me 4x. I bring down my greater than or equal to, and then negative 2x plus 2x cancels, leaving me just this plus 8, or positive 8. Now I'm going to divide both sides by 4. And x becomes greater than or equal to 2. Greater or equal to 2. All right, next example. We have 3x minus 1 is less than x plus 9. So again, I want all of my variables on the left-hand side, and this x is in the way. This is a positive x. So to do the inverse of a positive x, a plus x, I'm going to subtract x from both sides, leaving me on the left-hand side 2x minus 1. I bring down my less than, leaving me just a positive 9, a 9 on the right-hand side. Now I'm going to solve. This has become a two-step, so I'm going to take care of my